So let me show you a problem that looks extremely basic. I want to talk about father and son. I'm going to also talk about a ratio. Then I shall talk about an average. Last but not the least, I shall say add 11 years. So father and son, a ratio, an average, and adding 11 years. Most people see this and immediately think, oh, that's easy. But the problem is not really about finding ages. Then what is it about, if you wonder? It's actually about understanding how relationships stay stable while time moves forward. And once you're able to see that, you will realize this same idea, rather the same idea, shows up in domains like finance, in business, and even in machine learning models. Yes, you heard it right. It shows up in machine learning models as well. I want to talk to you about a problem statement, and it goes something like this. If the age of a father and son are in the ratio, let's say 3 is to 1 upon 2. If the age of a father and son are in the ratio 3 is to 1 upon 2, and the average of their ages is, let's say, 35, then what is the sum of their ages after 11 years? So let me read the problem statement for better clarity. If the age of a father and son are in the ratio 3 is to 1 upon 2, and the average of their ages is 35, what is the sum of their ages after 11 years? You know what? Before touching any numbers like 3 is to 1 upon 2 or 35 or 11 years for that matter, let us pause and think deeper. Why? If you think deeply about this problem, turns out this problem gives you 3 different kinds of information. So what are those? Let me call out one by one. First one, I'll say ratio. Okay? So I'll say ratio, which is about structure. Then the second one, I shall say average, which is about a constraint. I shall explain one by one. Let me state this information, what all it gives you. Okay, there is some spelling mistake here, and the structure, I'm going to clear up that. Okay, so let's say the third one. Okay, the numbering is not in sequence, but do not mind that. I'm going to call time shift, and what I mean by that is invariance. I shall explain one by one. This problem gives you 3 information. First is about ratio, which is all about structure. Second is average, that's about a constraint. And the third itself is about time shift, which I called invariance. So let me just explain one by one. Let's look at the first one, the ratio. Ratio doesn't give you the exact values, meaning Ratio will never give you the actual values. When you see the ratio 3 is to 1 upon 2, it is never about the actual value of the ages of two people. Then what it gives you, turns out, it gives you the structure. Meaning, it tells you how two quantities, in this case, ages of two people, that are father and son, actually relate. Not exactly what their ages are. Hope you get the drift. When I look at the ratio like 3 is to 1 upon 2, it reveals some information like this, which is clear. That is to say, father is older, son is younger, and their ages are locked into a fixed proportion. That's pretty much. Let's now look at the second information this problem is giving, which is about average. That is about constraint. So let me just explain. Average is powerful, make no mistake, because it gives you the total, isn't it? If I say if the average of two people is 35 as it is stated in the problem statement, this exactly means the sum of their ages right now is 70. Hope you get the drift. So now, what we know the shape of the system and the total weight of the system. That is important to recognize. The third information this problem is giving is what I called time shift. That's all about invariance. So what I mean is, when you add plus 11 years or when you add 11 years, this is where many people tend to mistake this, or let's say tend to overthink it. Time does not change the relationship between father and son, does it? Even if time passes, lots of the years go by, the relationship between father and son will remain intact. It does not change. Then what time does here? It just shifts the entire system forward. That's worth taking note. This idea, what I talked about, in the form of ratio giving the structure, average is about constraint, and time shift is about invariance. This very idea is what changes and what stays invariant is the real lesson of this problem. Now, let us try and solve this problem. I'm going to take a stepwise approach and call out certain steps in a structured manner to solve this problem. Okay, let's do that. Let's call the first one as step 1. That's the first step that I'm going to take. So what in the problem statement is given? We have ratio given. I'm underlining it here. Why it is not allowing me to underline? Let me just take a look and see if I can do this. Okay, so it's not allowing me, but I'll write it here nevertheless. 3 is to 1 upon 2. Yeah? But you see, 1 upon 2 is a fraction. 3 is a whole integer. To avoid fractions, there is the simplest way. Multiply everything by 2. Turns out the ratio becomes, I could write it like father is to son. If you multiply everything by 2, turns out 2 times 3 is 6. And 1 upon 2 times 2 is 1. This simplifies a lot of things. That's the first step. Second step, let's call that as step 2, if you like. And step 2 is about converting the ratio to actual ages. Okay, I'll write it that. Convert ratio to actual ages. So let us understand what is this step 2 in greater detail. In mathematics, it is very natural to assume x to be an unknown number. So does y. So let's say I'm going to call out, let son's age be, let's call it as small x. Then turns out father's age. Any guesses? You don't need to guess. 6 is to 1. Father's age is exactly 6 times that of son's age, and son's age is represented by a variable x or a letter x in the English alphabet. Therefore, the father's age is exactly 6x. So their total is father's age plus son's age. That means 6x plus x, that is 7x. That is our step 2. Let us go to step 3. So any guesses for what is the step 3? I think it's now directionally you're getting a sense. We already know sum of their ages is 70, isn't it? Because average is 35, so therefore sum got to be 70, which means what? 7x got to be equal to 70. If you simplify for x, it is exactly 10, which means son is 10 years old. We can say that comfortably, isn't it? And therefore, father is 6 times x. Father is 6 times, okay, give me a second. We will just get the pen aligned here. Yes, father's age is 6 times x, that is 6 times 10, which is equal to 60. So the age of the father is 60 years and that of the son is 10 years, right? So step 4 is what? As called out in the problem statement, we need to add 11 years. I'll just scroll up a bit and then show you in the problem statement what exactly is this. Yes, I'm reading it. What is the sum of their ages after 11 years? I'll just come to step 4, which means what? We shall name this step. I'll simply say move the time forward. Okay, some kind of description will always simplify things for easier following, which means what? I'll put it in quotes, after exactly 11 years as called out in the problem statement, isn't it? Son is how many years old currently? 10 years. So therefore, after 11 years, son would be adding the two numbers, 10 plus 11. So son would be 21 years old. Father is therefore 60 plus 11 would be 71 years. So what is asked in the problem? Let's scroll up. There is nothing to assume here. What is the sum of their ages after 11 years? We have just calculated in step 4. After 11 years, son's age is 21 and that of father is 71. Therefore, sum of their ages after 11 years is just a simple addition of 21 with 71. So therefore, we will have 92. As simple as that. This is our final answer. There is no complexity so far, isn't it? Everybody is able to follow the steps. But that's not the intent of this video. What is a significant value addition, or what is the real value in it? If you were to think deeply about it, here is the important part. As I started by saying in this video, this problem was never about ages. Then what is it about? It was always about learning, read structures from ratios. I'll put it in quotes. Read, I'll abbreviate structure as STR, from ratios. That's the first point that I want to call out. So it was about learning to read structure from ratios, extracting totals from averages. Extract totals from averages. That is what it was about. And last but not the least, it was also about understanding what time changes and what it does not. So I'll put it like that. Understand what, let's suppose, time changes. Yeah? I'll put it in the next line for better clarity. And what time doesn't change. Let's simply say what it doesn't. Yes, this problem was never about the ages, and therefore this problem was learning to read structure from ratio, or ratios in the plural I should be, I stand corrected. Extract totals from averages. Yes, you heard it right. Understand what time changes and what it doesn't. If we can do that, if we can reason about this kind of an approach, if we can exactly do what I did, you can also reason about, let's call it out, for profound applications now as key takeaways. Yes, if you understand this structured steps and realize it was about ratios, averages, and time invariance, you could reason about salaries, you could reason about investments. How good is it? Some of you are thinking of investing for future. You could also reason about experience. Yeah? Not just that, I'm going to make it a little more compelling. You could also reason about growth. I mean, we can go on and on, probably a lot lost. You could also even reason about learning curves. And that's what it is, my friends. Yeah? That's why problems like this, which look basic for most of you, turns out problems like this still matter. We have come to the end of this video. If you want to learn, quote unquote, how to think, not quote unquote, just calculate. Yes, I really mean it. If you want to really learn the right way about how to think, not about just calculate, please subscribe to the channel. On this channel, we don't rush to formulas here. We build intuition first. Thank you very much for your time. I hope you found this video useful. We will see you in the next video. Happy learning.